Pluto's direction has forever been a subject of interest and worry. From the start, Pluto's orbit has crossed with that of another planet, which normally brought up issues. Pluto, the cryptic and little divine body arranged in the farthest reaches of our nearby planet group, has turned into a successive theme of conversation in the field of space science. Recent disclosures have ignited alert, demonstrating a potential impact with Neptune, a situation that has caught the consideration of researchers and space fans the same. Prominent figures like Neil deGrasse Tyson and Michio Kaku have voiced their stresses over the potential ramifications of this heavenly experience. In any case, how did Pluto's way lead to a conceivable impact with Neptune, and what would such an occasion mean for Earth? Join us as we investigate the complexities of Pluto's excursion and why researchers are progressively worried about this inestimable oddity. Once hailed as an undeniable planet, Pluto went through a huge renaming as a dwarf planet, to a great extent because of the inconsistent nature of its orbit. Regardless of its downgrade, Pluto proceeds to enamor and interest those inside the cosmic community. Ongoing alerts from unmistakable researchers, including Neil deGrasse Tyson and Michio Kaku, have proposed that Pluto's orbit could converge with Neptune's, raising the expected gamble of an impact with broad outcomes for our planet. Pluto's orbit around the Sun is astounding, inferable from its particular elements. Its orbit is outstandingly extended, taking a shocking 248 years to complete. Since its discovery in 1930, Pluto has not yet finished a full orbit. What makes Pluto especially interesting is the exceptionally elliptical shape of its orbit, in stark contrast to the nearly round orbits of the major planets. Furthermore, Pluto's orbit is tilted at a point of 17 degrees relative to the ecliptic plane, resulting in a more extreme tilt than that of other planets. This mix of inclination and the stretched orbit adds complexity to its movement. An especially striking element of Pluto's orbit is its occasional crossing with Neptune's orbit. Every 20 years, during these periods, Pluto's path carries it closer to the Sun than Neptune, which challenges the normal relative positions of the two planets within the solar system. Further assessment uncovers that Pluto's orbit is far from an ideal circle. Rather, it follows an elliptical, oval-like path, meaning its distance from the Sun changes drastically throughout its orbit. At its nearest point, Pluto reaches around 30 astronomical units from the Sun, but at its farthest, it extends to over 49 astronomical units, almost double the distance of Neptune from the Sun. Also, Pluto's orbit is tilted relative to the paths of other planets, adding another layer of complexity to its relationship with Neptune. This inclination plays a pivotal role in how Pluto and Neptune interact. When their orbits cross, their gravitational forces interact, slowly adjusting their paths. This interaction highlights the interconnected nature of the solar system, where the gravitational influence of one body can affect the movement of another. With advances in observational technology, cosmologists have been able to track Pluto's movement with greater accuracy, leading to a clearer understanding of its orbit and its potential consequences for the overall stability of the outer solar system. While the probability of a direct impact between Pluto and Neptune is low, the possibility is still being carefully monitored. Researchers are concerned because the results of such an impact could be catastrophic. Despite its small size and remote location, Pluto remains an object of great interest for both scientists and space enthusiasts. A crucial question arises: why hasn't Pluto collided with Neptune yet? The answer lies in the gravitational influence of other planets. Since Pluto's discovery, cosmologists have been working to unravel its orbit. Unlike most planets, which maintain relatively steady orbits along the ecliptic plane, Pluto's orbit stands out due to its steep tilt and elliptical shape. The mystery extended when it became clear that Pluto's orbit crosses Neptune's, presenting a potential risk. Despite this, Pluto's orbit remains surprisingly stable, showing the intricate mechanics that govern the movements of celestial bodies. Focusing on the interactions between Pluto, Neptune, and the Sun presents a considerable challenge for astronomers. Predicting their movements requires an in-depth understanding of how they influence each other's paths. To navigate this complexity, Researchers use various models, such as libration theory and VSOP, variable state of planetary oscillations, along with theories like the Kaplan separation theory to unravel this cosmic riddle. For instance, libration plays a critical role in maintaining the stability of planetary orbits. When Pluto crosses Neptune's path, it stays at least 90 degrees away from Neptune, preventing a direct collision. Libration ensures that when Pluto approaches Neptune or any large planet, it is positioned above their path, reducing the chances of an accident. The VSOP model, named after scientists von Zeipel, Steves, and Kaplan, explains why Pluto's orbit appears unusual but remains stable over time. Although space may seem chaotic, there are hidden patterns that keep things in order and prevent Pluto from colliding with Neptune or drastically altering its orbit. The concept of orbital chaos, which refers to the sensitivity of a celestial body's path to its initial position, is clearly evident in Pluto's orbit. Even minor variations in Pluto's position or speed can cause significant changes over long periods. Researchers use advanced programmatic models to simulate Pluto's interactions with other bodies in space, like Neptune, and to explore the consequences of even the smallest shifts in its orbit. In the late 1980s, these simulations revealed an interesting finding. Despite Pluto's orbit seeming stable, it can still behave erratically. A small change in Pluto's initial position or speed could lead to enormous changes over time. However, even with these uncertainties, Pluto's orbit remains stable over billions of years, suggesting that, despite its tumultuous appearance, it follows an underlying order. The eccentricity of planetary orbits, like Pluto's, makes it difficult to precisely predict long-term changes. These models require highly accurate initial conditions, as even the smallest data errors can lead to vastly different outcomes, making precise predictions extremely challenging. Understanding Pluto's orbit is essential, especially when considering the potential for a future collision with Neptune. This knowledge helps astronomers gain a deeper understanding of the solar system's mechanics. Pluto's orbit serves as a perfect example of how seemingly chaotic paths can eventually achieve balance, directed by the forces of gravity and motion. It is crucial to continue observing and studying these celestial mechanics to better understand our position in the universe. Pluto's orbit perfectly illustrates the unpredictable nature of space. Its surprising oval-shaped path leads to irregular encounters with Neptune, making it challenging to predict the long-term dynamics of the system. However, gravitational forces play an imperative role in preventing Pluto and Neptune from colliding. Gravity, which attracts objects to one another, ensures that despite their intersecting orbits, the two bodies often remain separated. The likelihood of a call. Michio Kaku, known for his groundbreaking work in string theory, also offers valuable insights into the potential impacts of a collision between Pluto and Neptune. He emphasizes the importance of understanding the fundamental forces that govern the solar system and the universe at large. Kaku has speculated that such a collision could trigger a cascade of events that might affect the orbits of other celestial bodies in the outer solar system, potentially reshaping the cosmic landscape. He points out that the study of these distant bodies, like Pluto and Neptune, reveals the underlying order and chaos that coexist in the universe. The gravitational dance between these bodies, driven by the fundamental forces of nature, serves as a reminder of the delicate balance that governs the motions of planets, moons, and other celestial objects. While the possibility of a direct collision between Pluto and Neptune remains slim, Kaku acknowledges that the dynamics of the solar system are not entirely predictable, and unforeseen interactions could have significant consequences. As research and technological advancements continue, scientists remain vigilant in monitoring Pluto's orbit and its interactions with Neptune. The ongoing study of these distant objects not only provides insights into the stability of our own solar system, but also deepens our understanding of the broader workings of the universe. While the potential for a catastrophic impact remains unlikely, the mere possibility serves as a reminder of the dynamic and ever-changing nature of the cosmos. In conclusion, the journey of Pluto through space, with its eccentric and tilted orbit, continues to fascinate scientists and space enthusiasts alike. Its interactions with Neptune, though complex and rare, offer a glimpse into the intricacies of gravitational forces and orbital dynamics. The ongoing study of Pluto's path not only helps to refine our understanding of the solar system, but also raises important questions about the future stability of our cosmic neighborhood. Researchers like Tyson, Kaku, and others urge continued exploration and monitoring of these distant bodies, as they hold the key to unlocking many of the mysteries of space and our place within it. Kaku trusts that research peculiarities, like Pluto's circle, is fundamental for understanding the more extensive standards of divine mechanics and hypothetical material science. He recommends that analyzing Pluto's cooperations with Neptune can assist researchers with guaranteeing the security of future space missions. Kaku likewise stresses the significance of understanding gravitational powers in space investigation, as they could altogether shape how we investigate far-off universes. His work in string hypothesis, which tries to make sense of the key powers of the universe, lines up with his interest in Pluto's circle. A crash among Pluto and Neptune could give significant information that would add to how we might interpret gravity and space-time regions integral to string hypothesis. Albeit such an occasion would have insignificant direct effect on Earth, it could offer a novel chance to study the conduct of key powers under outrageous circumstances. As space investigation proceeds, the flightiness of planetary communications becomes progressively apparent. The investigation of heavenly elements, for example, the complicated gravitational connection between Pluto and Neptune, offers significant experiences into the central laws of the universe. By proceeding to screen and concentrate on these peculiarities, we draw nearer to disentangling the intricate idea of the universe. The gravitational dance between Pluto and Neptune highlights how even far-off planets can apply influence over each other. These divine bodies apply gravitational powers that, over lengthy periods, can unobtrusively yet essentially shape their circles. While a direct impact remains unrealistic, the probability can't be precluded completely, which keeps researchers and cosmologists on alert. Understanding these powers could one day permit us to anticipate and alleviate the dangers presented by such inestimable occasions. One entrancing part of planetary movement is the way seemingly irregular or turbulent associations can lead to stable, unsurprising examples. This is particularly evident on account of Pluto, whose circle could appear to be whimsical, however is, all things considered, governed by exact gravitational powers. These powers help keep Pluto from slamming into Neptune, in spite of the evident crossover in their ways. The fragile harmony between the gravitational draw of different planets and Pluto's circle keeps the Bantam planet on a consistent, but complex, course. Understanding this mind-boggling relationship is vital to propelling our information on the more extensive planetary group. As researchers keep on examining Pluto's circle, they additionally turn their attention to different areas of room investigation. For example, considering frameworks like TRAPPIST-1, which contains different Earth-sized planets, helps cosmologists comprehend how gravitational powers between planets can prompt orbital resonances. In some cases, these powers can undermine a planet's way, prompting flimsiness. However, the TRAPPIST-1 framework isn't encountering any crashes right now. Researchers continue to observe planetary developments within these packed conditions to better figure out likely dangers and their advancement over the long haul. In the interim, stargazers are likewise focused on figuring out the way of behaving of rebel planets, which travel through space without orbiting any star. As our investigation of room grows, the study of divine bodies like Pluto and the TRAPPIST-1 framework turns out to be progressively urgent for expanding our insight into inestimable mechanics. The investigation of rebel planets, which don't circle stars, offers one more layer of intricacy to our comprehension of planetary movement. These planets, floating through space without gravitational connections to any star, provide an intriguing challenge for cosmologists trying to interpret the wide range of ways planets can act and advance in the tremendousness of room. Their capricious directions can present new factors into the generally intricate dynamics of divine mechanics. and understanding them could offer crucial experiences into the development and evolution of planets and frameworks beyond our own nearby planet group. The flighty nature of Pluto's circle gives valuable illustrations in how divine bodies can follow apparently arbitrary ways, yet stick to profound basic designs directed by gravitational powers. In spite of its odd circular circle and shifted direction, Pluto remains a demonstration of the precision with which gravity administers planetary movement. By concentrating on such irregularities, researchers are revealing the administering laws of orbital elements and applying them to other divine peculiarities, assisting with anticipating and make sense of the way of behaving of far-off objects in space. Albeit the opportunity of a Pluto-Neptune crash is little, the plausibility itself keeps cosmologists on full alert. Understanding the gravitational connection between these two far-off bodies and their ways is significant for guaranteeing that future space missions and investigations don't suddenly encounter any hindrances. Despite the fact that an impact between Pluto and Neptune would almost certainly have negligible direct outcomes on Earth, it would still offer a significant chance for researchers to notice the functions of gravity and space-time under outrageous conditions, possibly offering new information to help continuous investigations in astronomy. Notwithstanding Pluto's strange way, the investigation of other comparable infinite abnormalities continues to provide understanding into the numerous mysteries of the universe. As our innovation and observational strategies further improve, researchers can refine their models of planetary and orbital behavior. This continuous exploration is fundamental for understanding the unpredictable dynamics of the nearby planet group and beyond, as each discovery adds to a more complete image of the universe's conduct. In particular, figuring out how gravitational powers impact the development of divine bodies gives critical information for arranging future space missions, particularly those daring to far-off exoplanet frameworks or into the external reaches of our own nearby planet group. One critical part of Pluto's circle is its reverberation with Neptune, a relationship that plays a key role in guaranteeing the stability of the two body circles. Despite the fact that their ways cross like clockwork, the gravitational powers between Pluto and Neptune are in sync so as to not impact the cautious harmony between their developments. This is a demonstration of the accuracy with which the laws of physics work, even in the most far-off regions of the planetary group. This reverberation helps prevent any potential accidents, ensuring that the planets continue to coincide without substantially altering one another's ways. This mind-boggling dance between Pluto and Neptune serves as a reminder of the vast order that supports even the most chaotic-sounding orbital mechanics. While Pluto's circle is a long way from ordinary, it is a prime illustration of how the universe works with a degree of accuracy, a request that isn't promptly evident. Regardless of its anomaly, the planet's way is impacted by the gravitational powers of adjoining bodies, which help maintain its dependability. Through continued perception and study, space experts continue to gain insights into how even the most apparently eccentric objects in space can be part of a much more coordinated framework.